Hey, my name is Marco Lisanek, and I'm going to talk to you guys and gals about recursion. You may have heard this word before, and it might sound a little daunting, but at the end of this video, I hope to make the topic of recursion more clear to you, and hopefully show you how useful it can be to solve complex problems. Recursion is a more elegant way to solve problems in computer science, so I'm going to explain to you what it is exactly and then go over some fundamental basic problems to show you how you can use it. So, a basic overview of what I will be going over in this video. We will define what recursion is exactly for those of you who have never heard of it before. We'll go into what the call stack is, and you'll see why this is important in a little bit. And then we'll run through some example problems, and finally go over some tips about approaching recursion problems and recapping on what we've learned in the video. So, what is recursion? The definition of recursion is a function that calls itself. It's when a function calls itself. Wow, that's pretty simple, right? Maybe not. This often confuses people because when they see a function calling itself for the first time, it can be confusing to tell what the function is going to return at the end of the vast amount of calls that will be executed. Recursion is essentially an alternative way to solve a problem instead of using loops. Any problem that can be solved using a for loop or a while loop can be solved using recursion and vice versa. So, now let's talk about the call stack. First, I want to point something out about JavaScript in general. JavaScript is a single-threaded language, meaning it can only run one function at a time. So, the call stack, or the function call stack, is used by JavaScript to see and know what function is running at any given point in time. It also keeps track of the order of the functions that still need to run, in case a function is calling itself, like in recursion. So, how many of you are lost now? Great, I am too. So, I'll leave you one last piece of information. When a function is called, it goes to the top of the call stack, and when a function is done running, it will be removed from the call stack. I just want you to focus on these two last bullet points right here for now. So, when you call a function, it goes onto the call stack, and when it's done running, it is removed off the call stack. Let's look at this example to further your understanding of what the call stack is, to show you what I'm talking about. It's really not that difficult. So let's look at these two functions I have for you right here. We have a function called first, which console logs the string I am first, and a function called second, which console logs the string I am second. And at the end, I will invoke first and I will invoke second. So when this page of code is being run, first goes onto the call stack, which is here, right here. First is onto the call stack, and it will remain on the call stack until it is done running. So we run the first function, and I am first is logged in the console. We'll think of this as our console. After it is done running, it is removed from the call stack. Then, our second function is being run, because that's first we invoke first, second we invoke second. So second is then thrown onto the call stack, and then while it's running, it console logs I am second, and you can see it logged here in the terminal, and then it is removed from the call stack in the same way. Now it's not looking so bad, right? The call stack is pretty straightforward. You call a function, it goes onto the call stack. It's done running, it goes off the call stack. Bada bing, bada boom. Easy peasy. So let's look at a more complicated example. Well, not really complicated, but it's a little different. So here you can see that function second is the exact same as the last example. It just console logs the string I am second. Now, we change the first function a little bit. So function first now will console log I am first, will then run second, and then it will console log first finish. So this whole page of code ends with first being invoked. So let's invoke first. Here's our makeshift call stack. So first is thrown onto the call stack. And as it's running, I am first is logged in the console because that's the first line of code. Then the second line of code, second is being invoked. And this is a function, so second is then thrown onto the call stack as well. And while second is running, it console logs I am second, and you could see that in the console. And when that's done running, second is then removed off the call stack. But first always remained onto the call stack because it never finished running. It was waiting for second to finish running. So it was paused. And now that second is concluded, it console logs first finish, as you can see here, and then, it's removed from the call stack itself. So hopefully you kind of understand what the call stack is about and what it how it's linked to recursion. So now I'm going to show you a little live demo of an example. So here I have a function that I wrote, and it's called countdown. It takes a number as a parameter, and it has a for loop which sets I equal to the parameter, and it loops until that number is equal to or less than 1. So it takes in a number, I is equal to the number. While I is greater than or equal to 1, it console logs I, and each iteration I is subtracted. So let's see what happens in the terminal over here. So I run enter. 5, 4, 3, 2, 1, undefined. Just so you know, this undefined right here is because that I wrote a function that is not returning anything. And when a function doesn't return anything, it implicitly returns undefined. But anyway, we wrote this function to give us a countdown. It counts down, starting from the number that's inputted here, and will give us 5, 4, 3, 2, 1 in the console. So, how do we do this without using a loop? Let's delete this loop. Well, the bare bones of this is essentially to console log the number, right? So we could do console.log num, right? And then when we run that, wait a second, we just get 5. So how can we do this to make it 5, 4, 3, 2, 1? Well, we can do this, countdown 4, countdown 3, and you see it does it like that, but this isn't programmatic. It won't just do it on its own. We have to keep calling it ourselves manually over and over again. So let's think about it. How do we do recursion? So basically, what recursion is all about is calling the function itself, right? That's the definition. So what are we going to do? We're going to call countdown. We're going to call countdown right here again. So we're going to call it. But what are we going to pass countdown? Now we're passing 5 in. Well, down here we're going to pass in 5, right? So we need it to count down. So 5, 4, 3, right? So let's try and do, how about num minus 1? This way, whatever number is thrown in here, it'll console log that number first, and then it will run this function again with 1 less. So if we put in 5, then it'll do countdown with 4, and it'll console log 4, and so on and so on. Wow, this is gonna be great, right? Amazing. Has anyone seen a problem yet? When is this countdown function ever going to stop? Let's run it and see what happens. Uh-oh, it's not stopping. That's because I entered an infinite loop. It just goes on forever and ever and ever and ever and ever. It's just an error. Maximum call stack size exceeded, because this function doesn't know when to stop. So, what do we need to get around this problem? What we need is something that is called a base case. The common practice when solving a recursive problem is to have and always have a base case. This base case is used to tell our function to stop. So, let's write a base case. What would be a base case? Well, I guess we can just do, basically, a base case can just be an if statement. So if num is less than 1, we're just going to console log, a string that says done, right? And then else, if it's not, we will do this. So now let's follow through this line of code with me. So this function will take in a number. It will check if that number is less than 1, because this is our base case. And if that number is less than 1, then it will console log done, and that'll be the end of it, because this if-else statement works like that. Else, if it's not less than 1, it'll console log that number, and then it will recursively call num minus 1. So let's see what happens. 5, 4, 3, 2, 1, done. That's great, right? So there you have it. There's your first function using recursion. So let's head back to the slides for a second. Okay. So, some key points of counting down. You always have to make sure that you have a base case. You need to. Otherwise, your function will never know when to stop, so it'll just run forever, and then the call stack will be exceeded. Oh wait, actually, let me, speaking of call stack, let me go back to this and show you what the call stack will look like. So, here we have the call stack, right? So first things first, here, we're calling it with 5, right? So countdown, comments, countdown of 5 is thrown onto the call stack, right? Just to give you a better example of how this is going down. So countdown of 5 is invoked, right? So you pass in 5 here. Is 5 less than 1? No. So else, you console log num 5, which is printed here, and then you return countdown of 5 minus 1, which is 4. So then 4, so countdown of 4 is thrown onto the call stack. So now 4 is then passed in through here. Is 4 less than 1? No. So console log 4, and then countdown of 4 minus 1, which is 3. And then this is thrown on to the call stack of 3. And now you get the pattern here, so like it's going to be 2, and then we're going to hit 1, right? So countdown of 2, and then countdown of 1. So let's see what happens when we throw in 1. So 1 is num, so is 1 less than 1? Oh, okay, well it's not, so right, I didn't set it equal to. So then we'll get to 0 after we do countdown of 1 minus 1, which is 0. So countdown of 0. So let's see. So 0 is 0 less than 1? It is. So we're not going to enter this block of code because it's in an if-else block. So we'll never console log and we'll never run again. Instead, we're just going to console log done, and that's the end of the function. So this is done. This is done. This is done. This is done. And it's all done. So that's how that works with the call stack. So, back to what I was saying. You should always also make sure that your recursive case changes the input so that it will eventually hit your base case. Otherwise, if it doesn't, like if we didn't pass in into the countdown num minus 1, if we just keep passing in num, then it will just run forever because the base case will never be hit. And that's just a no-no, you know? Now, I want to talk about returning values in recursion. So, when you have to write a function that returns a value, things get a little bit more tricky. Don't worry though, because you're listening to a very experienced and a very wise person who will explain everything to you very thoroughly. Once again, always remember to define your base case. If you're not sure what your base case should be, it will usually be something that has a simple input and simple output. Also, always make sure to test that your base case works. So let's do another example. We're going to write a factorial function, and this function is going to need to return something. So define a function that takes in a number and returns the factorial of that number. Just in case you don't remember what a factorial is, here are some examples. So it's essentially a factorial, how do I say this? A factorial is essentially the product of every number between the desired number and 1. So the factorial of 0 and 1 are simply 1. That's just standard. So the factorial of 2 is 2 times 1, 2. Factorial of 3 is 3 times 2 times 1. The product of the desired number and all the numbers in between that and 1. 4 times 3 times 2 times 1 is 24. It's the factorial of 4. Factorial of 5, 5 times 4 times 3 times 2 times 1, 120. Boom. So how are we going to write a function, and what do you think the base case should be? Let's check it out. in here. So forget about this error for now. So here I set up the basic skeleton of a function factorial. So what are we going to do? We need to find a way to return the factorial of whatever is in here. So if you remember back to the slides, what is the factorial of 1? Of 0? It's equal to 1, always. Always and foremost. So that sounds like a pretty good place to start with our base case. So we can just simply write an if statement. If num is equal to 1, or, that's the or sign in JavaScript, num is equal to 0, we're just going to return 1. That's it. We're returning 1. The base case has to return something if this function is going to return something. So now we have to write our recursive case. What are we going to do about that? Basically, we need a way to make it so that we'll eventually hit the base case. So what did we do last time? We ran the countdown function with the number -1. So what are we going to do now? We're going to do factorial of num -1. But hold on a second. How are we going to get, where's, like, if we put in 2 over here, what's going to happen? You know, like, well, let's just see what happens first of all. Factorial of let's see what happens. Let's test our base case. Factorial of 1, we get 1, which is exactly because our base case works. If we put factorial of 0, we also get 1 because our base case is solid, it works. We throw in 1 or 0, it returns 1, bada bing, bada boom. What happens if we throw in 2? Nothing. Nothing happens because nothing is being returned. Didn't I say that we have to return a value? So we put return. And we do factorial of num -1. What do you think the answer is going to be? What do you think we're going to get? If it's right, we should get 2. Ah, it's 1. Why is that? Because we're forgetting a key point about factorials in general. It's the number, it's the desired number times all the numbers in between, including 1. In between 1 and the desired number, all those numbers, it's the product. So we have to do 2 times factorial of 1, num -1. And then we get 2. So if this is right, then this should be 6. Ho ho ho. Oh, whoopsies. I put 2 here. It's supposed to be num, because it's programmatic. Otherwise, we'll just always get 2, and that doesn't mean anything. That's not a factorial. So this should be 6. This should be 24. 24, and this should be 120. Perfect. Now I will go over again the call stack. Because now we're returning a value, so it's a little bit different. So first off, once I put in factorial 5, I'm going to throw factorial, wait, hold on, factorial 5 onto the call stack. And this is returning something, by the way. So now we have return values, right? So this is returning 5 times factorial of 5 - 1, right? Which is 4. So now this is going to, this factorial 4 is a function, so that's going to be put onto the call stack. So factorial 4, and that will return, oh, whoops. That will return 4 times factorial of 3, because 4 minus 1 is 3. And this will return, I know this seems a little bit repetitive right now, but trust me, I'm trying to hammer it into you, so you know. Factorial, oh, whoops, factorial of 3 will return 3 times factorial of 2. Now, factorial of 2 will be 2 times factorial of 1. Okay, now this is getting a little interesting. As you can see, once again, our function is returning something constantly. So when we put in 5, it returns 5 times factorial of 4. And since it returns this function, factorial of 4 is thrown onto the call stack. Factorial 4 returns 4 times factorial 3. So factorial 3 is thrown onto the call stack because that's a function. And factorial 3 returns 3 times factorial 2. So yada, yada, yada. Once we get down to our base case, factorial of 1, once again, that's going to return something because it's not going to return the function again, so nothing's going to be thrown onto the call stack again. We hit our base case because num is now equal to 1, so now this is going to return 1. So now that this is done running, we know what this is, so this is just going to be 1, and this is going to be removed off the call stack. So now 2 times 1 is 2, so now this returns 2, and we know that. So this will be 2, and this will be taken off the call stack. So 3 times 2 is 6, so we know that factorial 3 returns 6, take it off the call stack. This is 6, 6 times 4, 24, so we know that factorial 4 returns 24, so this value is going to be 24. We take this off the call stack, 5 times 24, if you saw above, 120. Boom, and that's that. That's how the call stack works with recursion. And that's why it's understanding the call stack means that you understand recursion. It goes hand in hand, and if you understand the call stack more clearly, you will not have that much trouble solving simple problems using recursion. So let's go back to the slides. So some key takeaways from the factorial example. Define your base case and always start with it. And when you're thinking of defining what your base case is going to be, it usually is just something that takes in a simple input and gives you a simple output. It returns something simple, like 1. You know what I'm saying? Always test your base case with a simple input, just like we tested it with 2. We started the factorial testing with 2, because if you don't test your base case with something simple and something easy that you'll understand it, later on, if you just don't test it and you write your recursive thing, and then you write your function and you're done, and there's a big problem, debugging it is going to be such a pain. Trust me, believe me, it comes from experience. So always test your base case to make sure that it's working so that you know it's not breaking in the future. And then when you're done running your function, text it with a complex input to make sure that you've hit every edge case, you're aware of everything that could be thrown into your function, and the call stack is not exceeded. Okay. Now I want to talk to you about recursion and other iterables. So another thing about recursion in JavaScript is that you can use recursion with any data type. So that means that you can use recursion with strings and arrays as well. So if you're asked to recurse through arrays and strings, here's a helpful hint. The base case will usually be when the array or string has a length of 1 or 0. So for example, if you're trying to write a function to find the sum of all elements, like if you have an array of numbers and you're trying to find the whole sum of all the numbers, you basically want to say that your base case is when the array has a length of 1, because that will be the sum. So if you have a function, find sum, and the input is just an array with the number 4 inside, the length of that array is 1, so the sum is 4, because the sum of just one number is the number itself, so it's just 4. So this means that the recursive case must alternate the length of the array. So I'll leave you to solve this problem by yourself. It's not too bad if you understand what I just told you about recursion in the factorial problem and understand the call stack from the countdown problem. You can solve this no problem, but you do have to alter the length of the array to find the base case and to find the sum. So go ahead, try it out. Go for it. Now, anyways, let's do a little recap and some hints about approaching recursive problems. So now that we're, always remember to start with your base case, and I cannot stress that enough. It really is the easiest and cleanest way to tackling a recursive problem. You have to make, you also have to make sure that you test your base case to make sure it works with a simple input. It's just easier to test it with a simple input, and trust me, it'll just, if there's a problem with your recursive if there's a problem with your base case, and you try and write the recursive function, like I said before, I have experience doing this. It is almost impossible to debug it. Trust me, I know. Here's a helpful hint when you're trying to determine what your base case should be. Just think, what is your function returning? A base case and a recursive case should be returning the same type of thing. So if your function's asking you to return a number, your base case should probably be returning the number. If it's not, then recursion is probably not going to work. The two different types won't mesh correctly when you're recursively going through the function over and over again. And finally, if you get stuck, try to console log literally everything you can to see what the values are at each time, at each call point when each function is running. So you can get a bit. This is actually kind of, if you're still like a little fuzzy on recursion, it's kind of a good practice to just console log what the value of the parameter will be to see what it is, how recursion is doing, what step is coming when. If you still don't really understand what I'm telling you, but it's really not that bad if you just take a second and think about it. But yeah, using console log is a great way to debug your problems. Also, you can use the debugger tool in the Chrome DevTools, and also you can use the debugger tool in VS Code if you're using VS Code to write code. So, anyways, that's all I got. So, thanks for listening to me. Talk about recursion. Once again, this is just a very intro level overview of what recursion is. So I hope you learned something, and don't think it's as scary as it was before, because it's really not that bad. I hope you learned something from this video, and thank you so much for watching.